Hi, welcome to my YouTube channel. Today, I will show you the compliance pattern and the modified compliance pattern used in PCIe Gen 5. Here is the base specification for Gen 5. We go to section 4.2.8, which is the compliance pattern used in AB10B encoding. This compliance pattern consists of two sequences. The first one is the compliance sequence, which includes two K28.5 symbol, one with negative disparity, the other one has a positive disparity. You can see here, their bits are exactly complementary. And two D symbols, the D21.5 and D10.2. The other sequence is called the delay sequence, which is based on this compliance sequence appended or prefixed to D symbols. And this delay symbol or D symbol is actually K28.5 symbol. However, as we just showed, there are two 28.5 symbols. So which symbol should be chosen as the D symbol? That will depend on the current disparity. Basically, if the current disparity is 1, then this D symbol will be chosen to be the negative disparity K28.5 and vice versa. The table here shows the overall symbol configurations for this compliance pattern for AB10B. And this seems a little bit strange to me. This table contains 10 lanes instead of 8 lanes. I guess that's probably because this for some AB10B consideration. So very not exactly a normal configuration. Okay, so this is the compliance pattern, which is also short formed CP as CP. Next, let's have a look at modified compliance pattern, short formed MCP, also for AB10B encoding. As described in the spec, this MCP has one change against the CP compliance pattern. What is this change? The change is two identical error status symbol followed by two K28.5 symbols. If we look at this table of this MCP pattern configuration, I can see, yeah, here we have error symbol followed by two K28.5 symbol. Well, it's actually additional other symbol, which are two K28.7, 4 of them inserted there. So anyway, this modified component pattern is based on the component pattern with some additional error symbols as well as K28.7 symbols. And similarly, it's also based on 10 lanes. Here are the detailed explanations or definitions for each symbol. Next, We move on to the compliance pattern for 128B, 130B encoding. A question to you, my dear audience. Which generation of PCIe standards use AB10B, and which generations use 128B, 130B as their encoding format? Please put your answer in the comments. Thank you. And this compliance pattern for 128, 130B is much more complicated compared to the CP for AB10B. As stated here, this pattern consists of 36 or 37 blocks. So what are these blocks? First, the first block contains one sync header, which is 01B, followed by 128B unscrambled 64-bit 1 and 64-bit 0. Note these bits must be unscrambled. And the next block contains the same sync head, followed by also 128-bit unscrambled these symbols. Okay, and here we notice one difference from the matrix used by the patterns, two patterns, SCP and MCP for AB10B. In this pattern for 128B and 130B, the matrix is based on 8 lanes instead of 10 lanes, right? And in total 16 symbol. So it's 16 by 8, 128 symbols in total. The third block, sorry, it's not a third. Yes, third block, that's right. The third block contains same sync head. The sync head is always there for in each block. And also 128-bit unscrambled payload of another matrix of symbols, also 128 symbols. The fourth block is just one electric idle exit ordered set sequence. And the fifth, also the last block, consists of 32 data blocks. Each contains 16 idle symbols scrambled. So this is the compliance pattern for 128B and 130B. The last one is the modified compliance pattern for 128B and 130B. Wow, if you look at here, you can see this MCP for 128B, 130B is much longer than all the previous patterns we just introduced. It consists of 65,792 or 65,793 blocks. That's a lot, isn't it? So the first block is one electric idle exit ordered set sequence, and block 2 consists of 256 data blocks. They are just each of them just 16 scrambled idle symbols, and the last portion of the pattern consists of 225 sets of this sequence. Each sequence contains one skip or set, followed by 226 data blocks, and the same each block is contain 16 scrambled idle symbols. And note this is for non-Swiss. SIS means separate reference clock with independent SSC. So that means SSC is not enabled. That's my understanding. Probably it's not correct. If it's not correct me in the comments, please. However, when the SSA is enabled, which is case 2, then this modified compass pattern needs to use a different data pattern as shown here. The first one is the same EIE OSQ followed by 2048 sets of the sequence. The sequence is the same. So basically, they just replace this 256 data blocks with this sequence. Yeah, in essence, there will be a lot more skip or set added into this MCP for Swiss versus the MCP for non-Swiss. Okay, and you might have a question, where should the compliance pattern be used, and where the modified compliance pattern should be used. To find that out, you can copy this search, this modified compliance pattern in this PCIe test specification. I can see here this one. This test needs to use MCP, right? What is this test? The test for receiver link equalization for Gen 1. And this one is for Gen 4, also receiver link equalization test. And this one is for Gen 5. And what is this test? This test is, this test is for Gen 3. So basically, this MCP is used for receiver link equalization test, right? And for other tests like TX test or JETO test, you need to use CP, compliance test, instead of MCP. Okay, that's all for today. Have a nice day. See you soon. Bye.